Right guys, let's have a look at 10 then. We've got y equals 4x on the top, which is a linear power 1 polynomial, linear term. And you've got x plus 3, which is linear over x squared plus 2, which is quadratic, isn't it? So the order on the bottom, the highest power is cubed, so that's order 3. So it's like a third, so it is a proper fraction, so we can use partial fractions. And we've got a linear term there and a quadratic. So let's look at our cases then, to see what that corresponds to. There's two linears. Here's a linear and a quadratic then, just here. So in that case you write a over the first, plus bx plus c over the quadratic thing, the second thing that appears there. Because you want it a proper fraction, don't you? And so you need to introduce that bx to make it order 1 over order 2. Because that possibility can arise with a proper fraction, can't it? In this form. So that's the form then. It's case 2, it's quadratic factor. Let's go back to our question. Let's write down case 2, just to remind the reader that that's the case we're invoking here. So it will equal to then a over the first term, remember? Plus the bx plus c, wasn't it? All over the quadratic part, x squared plus 2. There we go. Now multiply through by the denominator as per usual. And then we'll see what to do then, shall we? So multiplying through by these two. On the left, we're just going to have 4x. On the right, times them by these two, we're going to have a. This will disappear, and you'll get x squared plus 2. Plus, now there's more than one term, so put a bx plus c, and you need a bracket because there's more than one term there, because you're going to times it by something. When you times it by the denominator, the x squared plus 2 cancels, and it just leaves the x plus 3, doesn't it? So that comes up the top there. So let's have a little look at this then. Now, there's an easy value to put in, isn't it? If I put minus 3 in, so let's just do that straight away without thinking too much. Put in minus 3. 4 times minus 3 is minus 12 equals, this will be 0. 0 times this will be 0. So you'll just get so many a's. Minus 3 squared is 9. Plus 2 is 11, so you're going to get 11 lots of a, aren't you? It's easier to write it that way around. And that tells you that a then equals minus 12 elevenths. Yeah, that's a. Great. Now, let's look back at this then. This is the line in question that we're going to look at. We've substituted a convenient value here. There's no other real convenient value, so the other thing we can do along with substituting convenient values of x, is to equate coefficients of powers. So we can equate the coefficients of x squareds on both sides, or the coefficients of x's, or the constants. That's just like putting x equals to 0 in as well. So we can do that. Now, what do you think then? If we did 0, we know a, and if we put 0 in, b will disappear, and we'll be able to find c, won't we? Yeah, so let's put 0 in. Or that's equating constants actually, but the easiest way to do it is just to substitute the value 0. So even though we looked at equating coefficients, we spent a moment looking at that and realized that, oh yeah, let's just put 0 in, and that makes the b disappear straight away. And we know a, so we'll find c, hopefully. So put in 0 in then. 4 times 0 into this line is 0. 0 squared is 0, plus 2 is 2. 2 lots of a then. 0 b's are 0. C, 0 plus 3 is 3. So you're just left with c times 3, which is plus 3c. So what does that tell you then? It tells you that move the 2a over here to minus. So I'm going to read from right to left. So that means I'm writing the 3c down. Move the 2a over to minus 2a then. And then move the 3 down. So c equals minus 2a over 3. Put the value of a in then. A equals minus times minus 12 over 11. So we get 24 over 33. There we are. There's c. Just put a double line on that. Just highlight that. That's the value of c. Now, the next easiest thing to do is x squareds, isn't it? Because c will not occur as an x squareds. So x squareds, let's have a look at that then. We're going to equate coefficients for x squareds here. How many x squareds are on this side? Well, there's none. So there's no x squareds on this side. How many x squareds on this side then? Well, if I draw the two lines, an x squared term arises here from the expansion of line 1 here on this bracket. So that would be a lots of there. And also when you draw two lines for the first and two lines for the second, you get 4 lines corresponding to 4 terms when you expand a pair of brackets, remember? The only x squared term comes from this product here, line 1. Bx times x, see it? So that's a plus b, isn't it? So that tells you then that b, move the a across the equals and read from right to left, b equals minus a. So b equals then minus a is minus 12/11, so it'll be 12 over 11. There we go, there's b. Great. So b is that then. Okie dokie. So now we can write the answer then. So y equals, it will be a over x plus 3 minus 12. Drop the 11 down to b with the x plus 3 plus bx plus c. I'll just write out the awkward fractions. Bx 12 over 11 times x plus c, which is 24 over 33, all over x squared plus 2. There's our answer then. Now we could tidy this up, because what you could do here is not too difficult to tidy this up. But if you look, that's an 11th, and that's a 33. So we could make this a common fraction here, 33. I could make that a 33 if I scaled up by 3 top and bottom. So I'm going to do that now. Scale up by 3 top and bottom, and that's 36 over 33, isn't it? So I'm going to replace the 12 11ths, if I can, by 12 11ths would be 3 lots on the top, so 3 12s are 36. 11 was on the bottom, so that's a 33, so I can write it like that. Equivalent fractions. And now that 33, you see, I can take that out common, and it's underneath, so I can drop it down here. So I'm going to do that, just to make it easier on the eye, and then that will get rid of the 33. The common fraction there, and the common fraction there, yeah? So you're left with 36x plus 24 on the top. So let me just write that tidily. 36x plus 24, I'll put that in now. And 36x plus 24. Okay, and you would probably want to write a fresh line actually, as if you were doing it. But since I can just scratch it out on the board, on this pad, that's no problem. That's the answer then that we've got for number 10. Good, we've done 10. We'll probably do another 10, 15 I expect of these, just to be absolutely comfortable with these sorts of partial fractions. Great stuff. Good. Let's go on to the next one then.